Hi guys, in this video, I'll discuss several techniques of integration that will help us solve integrals involving trigonometric functions, particularly powers and products of trigonometric functions. So for this lecture, we have actually four parts, but for the limited time that we are given, I will discuss as much concepts as possible. So let's get started. So we start with what we call reduction formula. So for this one, we actually have three formulas involving powers of sine, powers of tangent, and powers of secant. So in here, after doing the reduction formula, you will notice that from the left-hand side, the power of sine x is n, while on the right-hand side, the power of sine x is n minus 2. So you see that the power of sine has been reduced by integer 2. Similarly, on the left-hand side, the power of tangent is n, and on the right-hand side, the power of tangent is now n minus 2. So again, there is a reduction of power. And then, for the third one, the power of secant x here is n, while on the right-hand side, the power of secant x is n minus 2. So again, there is a reduction of power. That's why they are called reduction formulas. Now, you can pause the video to copy the formulas here and start memorizing them. But on the next slide, I want to show how these formulas are obtained. If you cannot remember what the form of the formula or what the form of this one is as a formula, at the very least, you know how it can be obtained. So let's start with the integral of sine to the n x dx. So for this one, the trick here is to separate one of the sine x on the left hand side. And then from here, we apply integration by parts. To do that, we can let u equals sine to the n minus 1 x, and then dv equals sine x dx. So if we find du, this will be equal to n minus 1 sine to the n minus 2x times by chain rule multiplied by cosine x dx, while for the v, we integrate sine x dx, and that's equal to negative cosine x. So applying integration by parts, we have uv, so that becomes negative cosine x sine to the n minus 1 x minus integral of v du. But there's a minus here, so let us just put this as plus integral of n minus 1 times sine to the n minus 2x cosine x. That's from the du. Of course, I have not written dx yet. But from the v, there's another cosine here, which means that this here is actually squared. And then we write the dx. From here, we recall the Pythagorean theorem, sine squared x plus cosine squared x equals 1. Or we rewrite cosine squared x as 1 minus sine squared x. So we use this Pythagorean theorem and replace this cosine squared x by 1 minus sine squared x, which means we will have here, so equals negative cosine x sine to the n minus 1x plus, I'll take out this constant here, n minus 1. So we will have n minus 1 integral of sine to the n minus 2x multiplied to 1 minus sine squared x dx. Then we can distribute this one here over this 1 minus sine squared x and then separate into two integrals, which will give us negative cosine x sine n minus 1x plus n minus 1 times the integral of sine to the n minus 2x dx minus, because of this minus here, n minus 1 integral sine to the n x dx. So you got n minus 2 here. If you multiplied here, you'll just add the 2 and that becomes your n. And notice that for this one, it's exactly the same. This particular integral here, it's exactly the same as this integral here. So we will bring this to the other side of the equation, which will give us integral of sine to the n x dx plus n minus 1 integral of sine to the n x dx equals negative cosine x sine to the n minus 1 x plus n minus 1 integral of sine to the n minus 2 x dx. And on this part, you got coefficient 1 here. You add n minus 1. So left-hand side, you will have n integral of sine to the n x dx equals this right-hand side in here. This right-hand side in here. So if we copy that, we will have negative cosine x sine to the n minus 1 x plus n minus 1 integral sine to the n minus 2 x dx. And of course, the last step is divide everything by this n. And you will get the formula for the integral of sine to the n x dx. So that's for this formula. So the trick here is, well, you just separate one of the signs and then use integration by parts. For the second one, let us do integral of tangent to the n. Integral of tangent to the n x dx. For this one, what we're gonna do is separate tangent squared. So we will rewrite this integral as integral of the tangent to the n minus 2x tangent squared x dx. And then from here, we will recall another form of the Pythagorean theorem, secant squared x equals tangent squared x plus 1. Or from here, we will have tangent squared x equals 1 or equals secant squared x minus 1. So in here, we replace the tangent squared x by secant squared x minus 1. So this is equal to the integral tangent to the n minus 2x times secant squared x minus 1 dx. And then we just distribute this tangent to the n minus 2x over this sum or over this difference, and then we separate the integrals. So in here, we will have integral of tangent to the n minus 2x secant squared x minus integral, oops, I forgot the dx minus the integral of tangent to the n minus 2x dx. Now, for this part, this is easily integrable by using substitution. We can just let u equals tangent x, du will be equal to secant squared x dx. So with this substitution, this will be equal to the integral of u to the n minus 2 du. For this one, we'll just keep it as integral of tangent to the n minus 2 x dx. And in here, we will have u to the n minus 1 divided by n minus 1 minus integral of tangent to the n minus 2 x dx. And finally, we will have here tangent to the n minus 1 x over n minus 1 minus integral of tangent to the n minus 2x dx. Okay? So we have that formula here. So I have done 1 here and 2 here. For you, as part of your homework in the future, you have to give the derivation of this integral of secant to the n x dx. Okay? So that's our reduction formula. Now, my tip here is if not needed, well, don't use the reduction formula. There will be some integrals where you will need the reduction formula, but there will be some integrals where reduction formula can be used, but there will be some other techniques that can be also used to solve that particular integral, as you will see later in the discussion. So that's for the reduction formula. Now we consider integrals of the form sine to the mx cosine to the nx dx. So this will be powers of sine and cosine and their products. Now if we consider this expression, look at this. Power of sine is m, power of cosine is n. So let us consider first the power of sine, and suppose that power is an odd number. Then m minus 1 will be an even number. In this case, we rewrite sine to the mx as sine to the m minus 1x sine x. Now notice the power of sine to the power of sine to the m minus 1x, which is m minus 1, is an even number. So m minus 1 can be divided by 2. In that case, you will rewrite this expression as sine squared x raised to m minus 1 over 2. So this one is an integer. Because m minus 1 is an even number, it is divisible by 2. So this expression is an integer, or this number is an integer. Now, look at this. We got here sine squared x. And if you remember the Pythagorean theorem that I have written earlier, that sine squared x can be written as 1 minus cosine squared x. Which means that if we bring back this expression here in this one, everything will be in terms of cosine. This will become something in terms of cosine times a single sine. And this one is cosine. Which means that we can use u equals cosine x. So all the expression in this form, where m is odd, can be written as in terms of cosine except for a single sign here. We needed this single sign here for this substitution. Take note that du, if u is equal to cosine x, du will be negative sine x dx. That's why we needed this sign here. Okay? So let us consider this expression. We want to integrate sine cube x cosine to the 4 dx. So essentially from here, we'll just take out one of the signs and the rest convert them into cosine. So this will be equal to the integral of sine squared x cosine to the 4x sine x dx. And this sine squared x here, we write it as the integral of 1 minus cosine squared x. Then we still have cosine to the 4x sine x dx. So now, if we do the substitution, u equals cosine x, du will be equal to negative sine x dx. So this will be equal to negative integral of 1 minus u squared u to the 4 du. Or this one will be negative integral of u to the 4 minus u to the 6 du. Or if you want to distribute the negative, we will have the integral of u to the 6 minus u to the 4 du. Now integrating, you will have u to the 7 over 7 minus u to the 5 over 5 plus c. And finally, if we bring back cosine, we will have cosine to the 7x over 7 minus cosine to the 5x over 5 plus c. So this will be the integral of this expression here. So again, we need the power of sine to be odd so we can apply this substitution. Next problem. Here we got sine to the 5x square root of cosine x. Then we want to integrate that with respect to x. So if you notice in our presentation here, it did not say what the power of cosine is. As long as m is odd, you can do this method. Okay? In this example, the power of sine is 5, which is odd. The power of cosine here is 1/2. It's a square root, right? So it's 1/2. So it's okay. In here, we can do this by rewriting sine to the 5x as sine to the 4x times sine x. And then we have our square root of cosine x in here, and then forget the dx. Sine to the 4x, this is equal to sine squared x squared. Square root of cosine x times sine x dx. And again, as in before, sine squared x can be written as 1 minus cosine squared x. Then we have here cosine or square root of cosine x and then sine x dx. So now we can proceed with the u substitution. Let u be equal to cosine x. Du will be negative sine x dx. So this one is now equal to negative integral of 1 minus u squared. And for this one, instead of writing square root of u, I'll write it as u raised to 1/2. U raised to 1/2. By the way, I forgot that there is a power 2 here. So this one is being squared, and this one is also being squared. And then this one here, we have the du. And now, we expand this. This will be negative integral of 1 minus 2u squared plus u to the 4 times u raised to 1/2 du. And we can distribute u raised to 1/2. We have negative integral of u raised to 1/2 minus 2 times u squared plus, or u squared times u raised to 1/2, that's u raised to 5/2, plus u to the 4 times u raised to 1/2, that's u raised to 9/2. Then we got the du. Integrating this, we will have negative integral u raised to 3/2 over 3/2 minus 2u raised to 7/2 over 7/2 plus u raised to 11/2 over 11/2 plus c. And finally, bring back cosine. We will have negative of cosine raised to 3 halves x over 3 halves minus 2 cosine to the 7 halves x over 7 halves plus cosine to the 11 halves x over 11 halves plus c. And this will be the final answer. Of course, you can simplify the denominators here if you want. You can bring the over 2 from the denominators going to the numerator and so on and so forth. But this one is completely fine. You can also distribute this negative sign here and that's still okay. So again, this is for the case when the power of sine is odd. Now, suppose the power of cosine is odd. Then we do the same. We can do a similar technique. Here, we don't know what the power of sine is, but we know that the power of cosine is odd. Then you do the same thing. This time, you work on your cosine to the n x. You separate one of the cosines. You convert the rest into in terms of sine. So you got this sine here, and then the sines from here, and then a single cosine. Then you do your substitution, u equals sine x, and du is equal to cosine x dx. That's why we needed this one. So very similar to the first part of this part here. Let's consider this example. So in here, we got cosine to the 5x, cosecant squared x dx. Here, power of cosine is odd. Here we got cosecant x, but cosecant x is 1 over sine x. So this one, you can convert it into in terms of sine. So here we have the integral of cosine to the 4x. Let us convert that. Let us take out one of the cosines. So cosine to the 4x times cosine x, and we have the dx. For the cosecant, we write it as 1 over sine squared x. And then, we write cosine to the 4x as cosine squared x squared. For 1 over sine squared x, I'll write it as sine raised to negative 2x. Or I'll put the power outside. So sine x raised to negative 2, then cosine x dx. Cosine squared x, that's 1 minus sine squared x. And then there's a square outside there. Then we have sine x to the negative 2, then cosine x dx. Then we can start doing u substitution. U equals sine x, du equals cosine x dx. Which means this will become integral of 1 minus u squared times u raised to negative 2 du. Then we expand 1 minus u squared squared as 1 minus 2u squared plus u to the 4, and that's still being multiplied with u raised to negative 2 du. Then we distribute, we will have the integral of u raised to negative 2 minus 2 plus u raised to positive 2 du. So integrating, we will have here u raised to negative 1 over negative 1 minus 2u plus u cubed over 3 plus c. Then finally, we can bring back u equals sine x. So you will have here, I will have 1 over negative sine x. That's from sine x raised to negative 1. So that becomes 1 over sine x. And of course, the negative here is still here. Minus 2 sine x plus sine cube x over 3 plus the arbitrary constant c. So that's when the power of cosine is an odd number. So very much similar to the first one. Power of the sine function is an odd number. Now, what if both powers are odd? Power of sine is odd. Power of cosine is odd. So power of sine is odd or power of cosine is odd. Then you just choose which method you want to use. Either this method or the first one. Both will work. Okay? Now, listen. As a tip, suppose you have that case. Suppose you have that case. Power of sine is odd, power of cosine is odd. As a tip, you want to use the substitution u equals the one with the lesser power. Okay? So again, if both powers of sine and cosine are odd, you use the substitution u equals the one with the lesser power. It will be more beneficial to you. So try to practice on those cases, several cases. You just try it. Now, what if the powers of sine and cosine are even? So of course, you cannot use any of the previous two techniques. For this case, we actually need to use these two identities. Cosine squared x equals 1 plus cosine 2x over 4. Sine squared x is equal to 1 minus cosine 2x over 2. Sorry, did I say over 4 earlier? It should be over 2. So anyway, cosine squared x equals 1 plus cosine 2x over 2. Sine squared x equals 1 minus cosine 2x over 2. So you just need to convert those sine and cosines. And of course, if, for example, you got here sine to the 6x, you have to write it first as sine squared x to the power 3. So you convert this one here using this um, identity. And then you expand it, and so on and so forth. Okay? Some students would do something like this. Oh, I got a 6 here, and it looks like it should be something like this. Sine to the 6x equals 1 minus cosine 6x divided by 6. Some actually do this, and this is not correct. Only for the sine squared. Only for the sine squared. Let us put that into a practice. So in here, I got integral of cosine to the 4x sine squared x dx. So for this one, we have the integral of cosine squared x squared sine squared x dx. Then we convert this into 1 plus cosine 2x divided by 2 squared times 1 minus cosine 2x divided by 2 dx. Now you will see this will take a lot of this will require a lot of work. It is what it is. This is the only way that we can do this. Or I have an or. You can convert this into sine, all of them, then try to use reduction formula. If you remember that reduction formula. Convert this one into sine. So from cosine squared x, you can write it as 1 minus sine squared x. You expand, then multiply the sine squared. Then you will just have all sines. If you have that, then use reduction formula. Anyway, let us continue with this solution. Here, I got over 2 being squared, so that becomes over 4. There's another over 2 here, which means I'll just bring out 1 over 8. Then the integral. And then you expand 1 plus cosine 2x squared. That will be 1 plus 2 cosine 2x plus cosine squared 2x. Then you multiply 1 minus cosine 2x dx. So again, like I said, this will be a long solution. You multiply these two expressions. So we will have 1 minus cosine 2x plus 2 cosine 2x minus 2 cosine squared 2x plus cosine squared 2x minus cosine cube 2x dx. We simplify this. We got 1 over 8. We will have 1 minus, actually it's plus cosine 2x. So that came from this. And then from this part here, we will have minus cosine squared 2x, and then we have finally minus cosine cube 2x dx. Now, if you notice, this one is easily integrable, this one is easily integrable, this one, you got power of cosine is cube. It's an odd power, so you can use the technique from earlier. Here, power of cosine is squared. You can use this technique as well, the current technique. So let us see. This will be 1 over 8 times integral of 1, that's just x, plus integral of cosine, that's sine, but you have to put over 2 because the coefficient of x here is 2. Okay? Now for this one, for the third one, we got minus integral. I got cosine squared 2x. Okay? If I use this same technique, I will have to write 1 plus cosine 4x over 2 dx. I will explain this part further a little bit later. As for the last one, we will have minus integral of cosine squared 2x cosine 2x dx. Okay? Now, let me just explain cosine squared x. This is equal to 1 plus cosine 2x over 2. So now, if I replace this expression here with 2t, the x with 2t, then this x here will be replaced by 2t, correct? Which means I will have cosine squared 2t equals 1 plus cosine 2 times 2t over 2, or that this will become cosine squared 2t equals 1 plus cosine 4t over 2. So that's why in here we now have 4x. So from 2x it becomes 4x. Okay? So now let me just copy this part here and use next page. So here we will have this expression. Of course, for this one here we can integrate easily. We will have 1 over 8 times x plus sine 2x over 2 minus 1 half integral of 1, that's still x, integral of cosine, that will be sine 4x here, and this time divided by 4 because the denominator, the coefficient here is 4. Take note that this over 2 here, it's now this part. And then minus integral of 1 minus sine squared 2x cosine 2x dx. So now we are left with this last part here. Okay, we can let u, or let's say let w equals sine 2x dw is 2 cosine 2x dx. So just for this part here, let me write the solution down here. We will now have 1/2 integral. The 1/2 came from this. So 1/2 integral of 1 minus u squared du, which is now equal to 1/2 u minus u cubed over 3. Then there's of course a plus c. Then we can bring back the sine function on this part here. And after doing that, we can now write the final answer as 1 over 8. Take note that that 1 over 8 is all the way outside. Then we got x plus sine 2x over 2 minus the 1/2 x plus sine to the 4, sine 4x over 4, then minus 1/2 u. Take note, sorry, it's not u. This is w. But anyway, w is sine 2x, so don't forget that. So this will be sine 2x minus sine cube 2x over 3, and then finally the plus c. And then don't forget that close parenthesis. So this will be the final answer. Okay? So like I said, if the power of sine and cosine are both even, you can convert one of them to in terms of the other and use reduction formula, or you can use this technique. In both cases, the solutions will be really long. And it just gets longer when these powers here increases or increase. Okay? So, I'm gonna stop at this point, and for our next session, I'll do the next two parts, powers of tangent and secant, and some more other forms. So, thank you and have a great day.